Good day, everyone. My name is Taras Puchko, and I am a PhD student in the Georgy Puchov Institute for Energy Modeling of the National Academy of Sciences of Ukraine. I am currently working under the supervision of Professor Saukh Sergii. Thank you for an opportunity to present a method of forecasting software development effort required for sustainable web API evolution. Web application programming interfaces are rules and protocols that allow distributed parts of software systems to communicate with each other. In the field of energetics, web APIs play a crucial role in facilitating data exchange, communication, and integration among various energy related applications, services, and platforms. As a mechanism for handling real-time, online, and historical energy data, web APIs can support interoperability in smart cities, facilitate decision-making for energy sustainability, enhance energy consumption operations, and improve efficiency in smart grids. After initial development, web APIs must continue to evolve to prevent themselves from becoming obsolete. Project managers need to know how often web APIs will change and what development effort will be required to perform such changes in order to plan months ahead and effectively allocate resources. In order to forecast software development effort for a particular time interval, one needs to predict the distribution of change requests and then estimate the effort for each change. The first part can be solved with a time series forecasting model. The existing literature shows successful forecasting based on both traditional methods and deep learning models, given change data exists for 7 to 20 years. However, the changes were not differentiated, so considering different types of them could improve the forecasting. An effort has to be estimated for each change predicted by the time series forecasting model. The methods to achieve that can be based on expert knowledge, size, model, analogy, regression, optimization techniques, fuzzy logic, machine learning, and artificial neural networks. We couldn't find any study of applying such methods to web APIs specifically, but taking that into account can improve the estimates. To forecast software development efforts needed to support web API evolution, we propose building a representative model that captures the historical patterns and trends. To demonstrate the proposed method, we have collected the API changes for 3 years from the Stripe API changelog and classified them. For each change type, we have built a representative model separately in the following way. The 3-year time series containing the change count was split into multiple 7-day time series. For each weekly time series, the mean and standard deviation of the change count were calculated and used to group the weeks into several clusters. For each cluster, a representative week was found. A forecast of change count was built by adding representative weeks proportionally to the cluster size. Based on that forecast and estimated effort of one change, a forecast of effort for a specific change type was built. The last step was combining forecasts for different change types into a single forecast. As a result, we have obtained a representative graph that does not predict exactly the effort required to support web API evolution for each day, but it captures the patterns and trends, allowing project managers to make better decisions on project budgeting, analysis of risks and trade offs, planning and controlling the project, and analysis of investments into software improvements. The proper management decisions effectively make Web API evolution sustainable when APIs are always able to meet changing requirements. Concluding, we can say that keeping Web APIs up to the task is crucial for the energy industry to meet the requirements of energy data access, renewable energy integration, grid management, smart home and building automation, energy market information, electric vehicle integration, energy efficiency and monitoring. To maintain Web APIs efficiently, we need a way to predict the future software development efforts. A representative model of future efforts can be built using cluster analysis of historical data. Such a model can be used in the planning process by organizations involved in building and supporting Web APIs. Future directions of research or improving forecast precision may include using machine learning techniques such as random forest ensemble learning method and multi-layer perceptron artificial neural networks. Thank you for your attention and time, and now I am happy to answer any questions you may have.